A very warm welcome to all of you today, and thank you for joining us for this, the first edition of our FeedForward webzine, called Say Goodbye to Sieve Analysis. Before we get started, you may be asking, why a webzine? What is a webzine? And why now? Well, we've spent the past few weeks talking to customers and colleagues in the feed business and reflecting on the COVID-shaped hole that we're all experiencing. Our conclusion? Just because we can't meet up in person right now, that shouldn't stop us from getting together and looking forward to the key challenges facing our industry and how we might solve them. Hence, FeedForward. In the coming months, we'll be live streaming episodes covering multiple topics, filmed with our clients, third-party experts, and of course, our very own specialists. Each episode will last around 20 minutes, plus a 10-minute Q&A session at the end, because we want this to be a two-way conversation. It's a little different, it's certainly experimental, but our aim is to provide some real feed for thought on how we can all thrive in the times ahead. So, we're kicking off today by talking about feed consistency, and in particular, the role of measuring particle size. We'll look at sieve analysis in practice, take a look at the potential for new optical measurement techniques, and get an overview of a new solution called GrainCam. With the help of our participants and yourselves, we then hope to answer the question of whether it really is time to say goodbye to sieve analysis. So, without further ado, we hope you enjoy this first episode.
Hello and welcome to the FeedForward webzine. Today is our first episode and it's called Say Goodbye to Sieve Analysis. We've got some fascinating insights ahead on this topic. So please send us your questions or comments and we will address to them in a live question and answer at the end of this live stream. Okay, down to business. As a feed producer, you must be able to demonstrate to your farmers the total control of the product you deliver to them. And that, of course, for many years. A major part of this centers on the precision of particle size distribution in your feed. And for many years, the industry has used sieve analysis as its measurement method. But Erik Ottevanger wonders if this old method still measures up.
75% of the feed is raw material related, and so let's say the feed producers they can influence only 25% of the total cost of feed. So it's very important to be efficient.
From the perspective of efficiency, let's take a closer look at the standard method for measuring particle size distribution, sieve analysis. To see how it works in practice, we spent some time earlier with Mr. Gijs Spruit from the Heus. Gijs is plant manager in Nijkerk, the Netherlands.
Op deze locatie produceren we pluimveevoeders en varkensvoeders. 260.000 ton per jaar. Wij horen van elke grondstof die binnenkomt een monster te nemen. 6 maanden op te slaan. Stel dat er een foute productie is, dan kunnen we altijd die monsters erbij pakken en laten zien of dat het wel of niet bij ons in de grondstof zat. Dus het is eigenlijk een controle voor ons van achteraf. En hopelijk hoeven we dat niet te doen, maar het heel af en toe dan komt het eens voor dat we een monster terug moeten zoeken. Wij kopen grondstoffen natuurlijk in met bepaalde waarden. Energie, vet, eiwit. Dus daar willen we zelf op kunnen controleren. Want aan de hand van die grondstoffen maken wij natuurlijk recepten. En als een eiwitpercentage in een grondstof niet klopt, nou ja, dan zien we gelijk dat we aanpassingen in de recepten krijgen. Maar dan kunnen ze ook terug naar de leverancier. Door grondstoffen zelf te onderzoeken bouw je ook een bepaalde historie op. Kloppen grondstoffen niet of hebben we productiefouten, dan wil je dat zo snel mogelijk weten. En dat kunnen we controleren doordat we dagelijks tientallen monsters opsturen. Nadat het product de menger heeft verlaten, dan zitten eigenlijk alle toevoegingen, alle vloeistoffen erop. En onder de menger, daar hebben we dan een bunker, een wachtbunker. En dat bunker dat kunnen we laten afvoeren naar de persmeelcellen, naar de perserij of naar de bulkverlading. En pluimveevoer gaat eigenlijk altijd richting bulkverlading. En daar tussen dat bunker en de afvoerelevator, daar zit een monsternamenpunt. Wij krijgen een monster vanuit de automatisering. En daar wegen we 5 ons van af. En die gooien we in de sieve. En die heeft een bepaalde tijd, staat die ingesteld. Als die tijd om is, dan wegen we alle 7 apart uit. En dat rekenen we om in een percentage en dat gaat in de procesautomatisering. En daarmee kunnen we de kwaliteit van het voer goed controleren. Nou ja, dit neemt best wel tijd in beslag. Ja. Dan ben je toch gauw tussen de 5 en de 10 minuten bezig met het invoeren in de automatisering. Wij hebben de regel dat we zo'n 10, 12 monsters per dag nemen. Dus met 3 ploegen. Dus iedere ploeg neemt 3 tot 4 monsters over zijn werktijd. En dat kan soms zijn dat er eens een uur, 2 uur tussen zit. Maar het ligt er natuurlijk net aan wat we aan het produceren zijn. Maar gewoon die 4 monsters, daar komen we wel aan. Klanten verwachten natuurlijk een goede kwaliteit. Een klant is denk ik niet gelijk geïnteresseerd of er met een bepaalde machine gedraaid wordt. Het gaat om dat hij de juiste kwaliteit krijgt en constante kwaliteit. Dus niet de ene keer veel te grof en de andere keer veel te fijn of een hele harde korrel en een hele slechte korrel. Constantheid is veel belangrijker.
Wouter Bak, you are a specialist in optical measurements and educated at Wageningen University. Do you recognize the challenge that Gijs Spruit brings to the table?
We saw at the Heus is that they already have a very effective and professional way of collecting the sieve samples. Nevertheless, the sieve analysis is still a time-consuming task. This is even more the case at other feed producers that may have less automation in place to collect those samples. What we see in the sieve analysis is that every recipe flows differently. So recipes with a higher fat content or a rather high moisture content take more time to arrive in the appropriate sieve. And therefore this results in differences of the measurement. So every recipe would ideally have its own optimized sieve time, and that is very hard to implement in practice. So as a result, you will have differences in the sieve samples, and these become even bigger if operators also have different practices to collect the samples, and that's what we hear from feed producers in the field. The most important disadvantage of this method, however, is the low sampling rate and the late availability of the sample. So a truck of 32 tons is typically sampled only once, and this sample becomes available only after the truck is fully produced. And if you would like to correct for a change in ingredients, then this is too late and the truck is already on its way to the customer.
Erik, you were looking for a more efficient solution. How did this search start?
Yeah, well, we were always looking for ways to make our processes smarter and more precise. Mm-hmm. And after talking with Wouter Bak about his optical measurement technology, things fall into place. My father spoke with Wouter, and Wouter was explaining about his work. And then, well, I was triggered by that. And, after discussions with Wouter, sitting together with him, we were also looking at possibilities, discussing possibilities in our industry. And the first thing we did was focusing on grinding, because controlling the particle size or particle size distribution is quite important in our industry. If you can measure this online and control your system, adjust online your grinding, your hammer mill, for instance, or your roller mill, and you can immediately respond and improve your process.
The conversations between Wouter and Erik led to the creation of a solution called GrainCam. Wouter teamed up with Ottevanger to test the prototype via an early adapter program, which has now been piloted at several customers for some months now. So, what is this GrainCam and how does it work?
The GrainCam is an online measurement system. It's a camera that collects images every 30 seconds. The system is placed below the mixer. And you see the camera system right here. It consists of two different LEDs. There's a high resolution camera on top. You see here the operator screen with the camera image right here. You see the individual sieve fractions that you also have in your sieve analysis. We have the average kernel size and the top 10% of the kernels. And in case either one of the sieve fractions exceeds the bounds that you have set for that recipe, an alarm message is shown and the color of this cell lights up, and the operator can immediately adjust for this change in ingredients, and thereby it can make the recipe according to the specs. It's an online and real-time measurement system that allows you to immediately adjust your milling process.
So in a nutshell, it's a digital camera. It gathers data on kernel size distribution and it sends it instantly to an online dashboard which organizes and stores all the data. One of the GrainCam pilots has started up about 2 months ago at the Heus. Gijs Spruit from the Heus takes up the story of his first-hand experiences.
Hier hangt de GrainCam. Hij zit in het kettingtransport. Je ziet hier ook de charge van het pluimveevoer gaan. Je ziet om de zoveel tijd dat hij een flits geeft. Daar was hij. Dan maakt hij een foto. Nou ja, het product kan via de mixer of eromheen. Maar de camera die pakt hem voor die tijd, dus die pakt echt elke charge. Ongeveer half maart is de camera geplaatst. Nou, was best gelijk al interessant natuurlijk om te zien. De plaatjes die hij nam van het voer, kan eigenlijk heel goed alle deeltjes zien. En daarnaast stond gelijk een analyse van de foto. De dichtheid van die GrainCam is natuurlijk heel hoog, want momenteel maakt hij iedere minuut doet hij een analyse. Dus van een charge zien we soms wel 4, 5 foto's. Die foto's die slaat hij allemaal op en die komen in een database. En op een gegeven moment pakt hij gewoon het aantal foto's van een partij en daar pakt hij de gemiddelde waarde van. Dus op een partij van 32 ton waar wij maar 1 monster van nemen, pakt die GrainCam rond de 35, 40 monsters. En die laat die eerst allemaal zien, maar op een gegeven moment slaat hij die als één waarde op. En dan heb je dus toch een gemiddelde waarde van 40 monsters. Dus dat zegt veel meer dan dat ene monster wat wij pakken. Op het moment dat we met de GrainCam begonnen, had hij bepaalde waarden, gaf hij weer. En daar zaten waardes bij waar we best wat mee konden. Maar op een gegeven moment kwam door de gesprekken met Wouter de Bak en kwamen we toch wel zover dat we hebben veel meer aan de juiste zeefanalyses zoals wij ze ook maken. Dus de zeven, 4 en 2,8 millimeter, et cetera. En toen op een gegeven moment was het zo van, dat kunnen we er ook wel in maken. En eigenlijk een week later zat dat erin. En toen kreeg het voor ons veel meer zicht. Toen konden we veel meer vergelijking trekken met onze eigen zeefanalyse. Dus dat was echt een mooi moment. Die camera die maakt hier heel snel een analyse van. En daar was weer een nieuwe foto. En dan is dit de laatste regel. En dan zie je hier dus de structuur, de fijne delen, de middendelen en de grove delen. Het systeem is ook gemaakt om bijvoorbeeld te zien dat een hamermolen even kapot zou zijn. Dan zie je heel snel natuurlijk grove delen erin. Die camera die geeft ook aan als het buiten de norm valt. En dat kan 1% zijn, maar dat kan ook 10% zijn. En als hij dat gewoon een aantal keer achter elkaar geeft, dan is dat toch wel voor ons in ieder geval een teken dat er iets aan de hand is. En dat kan zijn dat er iets aan een recept mankeert, maar het kan ook zijn dat er iets aan een grondstof mankeert. En als wij zien dat die camera steeds foutmeldingen geeft, dan moeten we daar natuurlijk op inspelen. Ik verwacht eigenlijk dat die camera zo goed en zo nauwkeurig gaat werken, dat die misschien wel de vervanger gaat worden voor de reds. Zodat we helemaal op de camera vertrouwen en daar de zeefanalyses van gaan gebruiken om de kwaliteit te verbeteren. Ja. Die camera kan de reds gaan vervangen, ja.
Thank you so much, Mr. Gijs Pruit from the Heus. Your story was very insightful. So, Erik, what can your customers expect in the near future?
Yeah, well, we believe that with the further development of the GrainCam, that we can create a new industry standard.
Wouter, what can we expect about the ongoing research and development?
We have just started with the GrainCam with a number of pilot projects, and at the moment we can measure a large range of different chicken feed recipes, and we try to expand that to the full range of all possible chicken feed recipes. And in addition, we're looking beyond the chickens only, so we also analyze pork feed, for instance, and we started a new track with NIR measurements to analyze the moisture content of the feed. And in the end, we would like to merge both sensors into one dashboard.
Well, Wouter and Erik, thank you very much for sharing your thoughts on this topic. A special thanks to our guest, Mr. Gijs Pruit from the Heus. Your story was very insightful. Based on what we've told us about the GrainCam and its potential both now and in the future, it seems like we really could be saying goodbye to sieve analysis. The next 10 minutes, it's time to tackle your questions you've kindly sent to us. Let's have a look. First question. I am wondering if it takes a long time to install the GrainCam, and do I have to close my process down? Wouter, I think it's a typical question for you. Please.
Yes, so it typically takes about 2 hours to install the window of the GrainCam, and then you need to close down your facilities.
Okay.
And furthermore, it will take the rest of the day to place the cabling of the camera system. So altogether, it's about 1 day.
So within 1 day, it's all up and running.
That's right.
Okay. Next question. What is the maximum material speed in meters per second? Okay, possible past the camera, which is possible while still getting acceptable images? Wouter, again.
This is in principle endless, because we can customize the system with stronger flashlights. And at the moment we have a very intense flashlight, meaning that we can handle, at the moment 1 meter per second, but I think even faster than that would be possible.
Okay. Can you explain the accuracy of the results of the measurements?
Yes, at the moment we are measuring the 5 individual sieve fractions, and they show a deviation of about 2 to 5% from the sieve analysis. And furthermore, we saw that for the average kernel size, that's in millimeter, the deviation is about 0.1 millimeter.
Okay. How near or how far the values are the values in GrainCam from sieve analysis? Also a technical question, I think, for you, Wouter.
Yeah, so the sieve fractions are about, the deviation is about 2 to 5%, but with every software update that we do, this tolerances become smaller because the software is improving all the time, and we do about 2 to 3 updates per year, which is included in the support of the GrainCam. So we're talking about a measurement system that's getting better over time, and that's of course a big difference with the sieve tower.
Okay.
Yeah.
Thank you. Erik, there are coming a lot of questions in now. I think the next question is for you.
Yeah.
Can I sign up for a pilot project, and of course, how does it work?
Yeah, well, we have a few places left on our early adopter program. We ask a commitment of 50% of the investment,
Okay.
Plus the user feedback for further improvements, which benefits, of course, your own operation. And then after 6 months, we conduct a review. Then either you keep the GrainCam by paying the residual 50%, or we dismantle the system without further cost. So for more info, just contact us directly after this broadcast or your area sales manager.
Yeah. So when I want, I contact the area sales manager or you, and then we're ready for the next step.
That's right. Yeah.
Okay. Next question. With the GrainCam, could we look after the color difference?
Yeah, that's possible. For the coating process, you could place the GrainCam before, let's say, the coater, and one behind, and then you can analyze the color consistency of your pellets or extrudats. Yeah.
Okay, and from the same person who asked this question, the next question is, could we evaluate the distribution between dark and clear particles?
Well, I think that is an interesting question for Wouter. I pass that one on.
I think so, yes. Please, Wouter.
Yes, of course it depends a bit on the application, but color detection is a very strong aspect of the GrainCam. We use it, for instance, for batch cross-contamination to analyze how much remnants of the previous batch are still in the next one. And I think the application that the person is referring to is very interesting, and I invite him to further discuss this application.
So it's all possible.
Yeah.
Okay. Then, Erik, next question for you. How much does this GrainCam cost, and also what is the billing model?
Yeah, well, there is an initial investment for the equipment hardware, and to be determined based on the, let's say, the individual customer situation and scope. plus a small monthly fee for the GrainCam cloud service and the GrainCam dashboard maintenance.
Okay.
Yeah.
Then I'll first introduce a short story before I'm asking the question. So sieving is based on weighing. GrainCam analysis is based on image analysis. These are two different principles giving different or numerical results in particle size distribution. And now the question is, which one should be used in future practical feed manufacturing? Wouter.
Yes, it's correct that it has different properties.
Okay.
There's however also a similarity. The GrainCam analyzes pixels, and our pixel size is 18 microns, and we use those pixels to analyze the size of the individual kernels.
Okay.
With your sieve tower, you're also analyzing, in principle, the size of your kernels. However, you divide them into different sieve fractions. So still you can make a good comparison between them.
Okay.
But the biggest advantage of the GrainCam is that you have a very high sampling rate and you get your results immediately, making it possible to sample like 30, 40, 50 or maybe 100 times along a truck.
Wow.
And in case nothing is happening and everything is in perfect condition, that's maybe not such a big advantage. But in case something goes wrong, you want to know that immediately, and that is the strong aspect of the GrainCam.
Wow. Okay. Next question. I'll pick this one out. Can the GrainCam be used to evaluate mixing homogeneity? Also, a typical question for you, Wouter, a technical issue.
Yeah, we demonstrated at the Victim Fair an example of the mixing variation,
Okay.
where we analyzed the color changes along the image. This is still a capability of the GrainCam. The focus of the last months has been on the particle size determination. But still, this is an interesting option to further explore. And we're also looking into validation methods to compare the mixing variation with another instrument.
Okay.
However, this is not so common. Like for the sieve tower, you have a very common instrument which is easy to compare to.
Yep.
But for the mixing variation, this is more challenging.
Cool. Okay. Erik, next question, I think it's perfect for you. What types of feed are compatible with GrainCam?
Yeah, well, right now, poultry and pork data has been included in the software.
Okay.
But basically, there's no limit. Duck feed, pet food, ruminant feeds, they're all perfectly feasible.
Yeah.
Yeah.
Okay.
So a whole range of formulations and feed. Yeah.
Very clear. Yeah. Next question. What is the smallest particle size that can be detected?
I think Wouter already answered that. Huh?
Yeah, it's on the one hand related to your pixel size, which is 18 micron in this case.
Yeah.
And on the other hand, it's also related to the texture of your feed component.
Mhm.
So in case we're having extremely homogeneous product with like white powdery mill all over, then this is also somewhat challenging to measure. But the feed types we saw so far, and also including monocomponent components, have a lot of structure in it, a lot of texture variation, which makes it possible to analyze the size variation.
Okay,
Yeah.
perfect. Next question. What is the maximum number of categories which can be created?
At the moment, we're working with 7 categories. So the 5 C fractions, we have the top 10% of the biggest kernels, and we have the average kernel size, 7 fractions in fact. But this can be expanded, because the GrainCam has in fact an infinite range.
Yeah.
Yeah.
And also the question related to this, to your answer, then the former question is: can it be used to equate to 8 sieves rather than 4 or 5 sieves?
Yes, I think that's definitely possible. Yeah.
Okay.
Yeah.
Good. Next question. How can avoid demixing mainly the fine particle fraction sitting at the measurement window? I think also a technical one for you, Wouter.
So does he mean that there is like the throughput of the feed through the conveyor? Or?
I don't know. I think so, but please.
Yeah, well, at the moment the conveyor is running in front of the glass of the GrainCam.
Okay.
So the feed is continuously refreshed.
Yeah.
And in that sense, there is no accumulation of feed in front of the camera.
I believe the question was more about detecting segregation of feed. Huh? So in front of a window. So that comes back to your previous question. If it's possible to analyze mixing accuracy.
Okay.
Yeah. But that is a more challenging task.
Yeah, it's a more
But
challenging.
it can be detected. Yeah.
Okay.
Yeah.
Okay.
Yeah.
Thank you for your addition. Next question. What measurement is used to determine the dimension, like length, width, median, diameter, and could we choose it? Wouter.
We made an analysis of all those different possibilities, and we chose the ones that correlate the best with the sieve tower, because that's the industry standard at the moment.
Mm-hmm.
And I think it would be too complicated for a user to allow him to customize those aspects, unless we're talking about pellets, for instance, where the length-width ratio is definitely important. But for mixed feed, I don't think it's a very important aspect. So we basically selected the one that correlates the best to the sieve fractions.
Right.
Yeah.
Right. Okay. Then it's already time for our last question. So our last question is, I think last question perfect for you, Erik. The GrainCam can be placed at other points in the process. Can you tell us a little bit more about this?
Yeah,
please?
well, let's say for example, if you're milling mono components, you can place the GrainCam directly after a roller mill or a hammer mill. For the coating process, you could place a GrainCam before or behind the coating.
Okay.
The GrainCam can also be used for both, let's say, product intake or finished feeds. So we're absolutely open to discussion.
So it's customized.
Yeah.
Okay. Good. Well, thank you for that last question. We're out of time now, but please remember, the chat will stay open. So if you have any more questions for us, please get in touch. And of course, thanks again from all of us here for watching and taking part.
And that brings us to the end of this first edition of Feed Forward. We'd love to hear your comments and feedback on this format, what you liked, and maybe some ideas for improvement. The live chat will stay open until 1 p.m, so please keep posting your questions. In the chat comments, you'll find useful links, including a written digest that summarizes GrainCam and the benefits it provides. And if you want to get in touch with us afterwards, you can do so via email or follow us on social media, where we'll continue to post responses to your comments. In the meantime, we hope very much you'll join us for episode 2, which focuses on new ideas and technologies for storage in the feed mill. Until then, stay safe and keep looking forward.